Oh, so we have the inverse linear function, and it's f of x equals 1 over x, and it has odd symmetry because it doesn't like flip over the y-axis or anything, and it's not bounded, and it has asymptotes at x equals 0 and y equals 0. Infinite discontinuity at x equals 0, and it only decreases because you're reading it from like left to right, and no extrema, and the end behavior is that, and the domain and range is negative infinity to 0 and 0 to infinity, and that's the same for the range.
Okay, so for the absolute value equation, this is f of x equals the absolute value of x, and then here's the graph. The domain is from negative infinity to infinity because it keeps going all the way to the left and all the way to the right. And then for the range, it starts at 0, so it includes 0 and goes to positive infinity all the way up. And then for symmetry, it's even. Boundedness, it's bounded below because you can put something here and nothing go through it. For asymptotes, there is no asymptotes and no discontinuities. And it increases here from 0 to infinity, and then it decreases from negative infinity all the way to 0. And the extrema, there's an absolute minimum right here of 0 at x equals 0. And the end behavior is the limit while x approaches infinity is infinity because it keeps going up, and then the limit as x approaches negative infinity is also infinity because it keeps going up to the left.
Alright, so for the logistic function, the equation is 1 over 1 plus e to the negative x, and the graph looks like this, with 2 horizontal asymptotes, which are shown here. The domain is from negative infinity to positive infinity, and the range is from 0 to 1. There's no symmetry. It's bounded above and below. The asymptotes there are no vertical asymptotes, but the horizontal asymptotes are at y equals 1 and y equals 0. It is continuous. It increases at negative infinity to infinity. There are no extremas, and the end behavior as x approaches 8 equals 1, infinity equals 1, and as x approaches negative infinity equals 0.
The sine function, the equation is f of x equals sine of x. There's odd symmetry. It's bounded both below and above because it's oscillating. There's no asymptotes, and it's a continuous line. The extrema, the absolute max of 1 is 1, and the absolute minimum is negative 1. The limit when x approaches infinity does not exist, and the limit when x approaches negative infinity does not exist.
Okay, so this is the square root function. The equation is y, or rather f of x equals the square root of x. This is the graph right here. The domain is all positive numbers as seen here, as is the range. There is no symmetry, and it's bounded below since there's nothing below the y-axis. Well, there's a limit at the y-axis. There are no asymptotes or discontinuation, and it's increasing from starting at 0 up to infinity. There is an extrema of an absolute min of 0 at 0. The end behavior is from x to infinity is infinity, but from x to negative infinity there is no end behavior since it doesn't exist.
Okay, and you guys need to write that out as 2 limits. Okay. So you need to write it out. Limit of f of x as x approaches negative infinity does not exist.
Hey, we got the cubic, hey, I'm Sid, follow me at Sidward. We have the cubic function here. Its equation is y equals x cubed. It's pretty beautiful. The domain is, it spans over negative infinity to infinity, and the range is also negative infinity to infinity. It is symmetrical in regards to the origin, so it is odd, and it is not bounded. There are no asymptotes, and there are no discontinuities. It is a continuous function. It's increasing from negative infinity to infinity. There's no extrema, and the end behavior, the limit of f of x as x approaches negative infinity is negative infinity, and the limit of f of x as x approaches infinity is infinity. And follow me at Sidward.
This is the cosine function, so it's f of x equals the cosine of x. The domain is all numbers, and the range is between -1 and 1. It's even. It's bounded above and below because it oscillates. There are no asymptotes, and it's continuous, and the extrema are at absolute max of 1 and absolute min of 1, and the end behavior towards infinity and negative infinity does not exist.
So this is the greatest integer function. The equation for it is f of x equals x in brackets. So with this function, the function of x or y is it's pretty much x. Well, dang it.
Where you at?
So it's the x, the greatest integer less than x. There we go. And so this goes on forever and ever. So there's no boundedness and no asymptotes because it just keeps on going. And there's no symmetry because it keeps on jumping. And discontinuity, it jumps at x, element of all integers. And because it jumps, we said it doesn't increase or decrease. And there's no extrema. And the end behavior is limit f of x equals infinity when as x approaches infinity, and limit f of x equals negative infinity when x approaches negative infinity. The domain is negative infinity and infinity, and the range is all integers, or y such that y equals all integers.
Is an element of.
An element of all integers, yeah.
Okay, good. Good job.
This is a linear function, and the parent function is either y equals x or fx equals x, and the symmetry is odd. It is unbounded, and there's no asymptotes. It is continuous. There are no extremas, and the domain is negative infinity to infinity. The range is negative infinity to infinity. The end behavior is limit fx equals negative infinity x to negative infinity, and limited fx equals infinity to x equals infinity. And it increases by negative infinity to infinity.
The logarithmic function is f of x equals log of base b of x. There's no symmetry, no extrema, it is not bounded, and there is no discontinuity. For the asymptotes, there is no horizontal asymptote, but the vertical asymptote is x equals 0. It is increasing from 0 to infinity. The end behavior is it's limited going x to infinity, and then it's limited going x to negative infinity.
The quadratic function is symmetry is even, so boundedness is below. Asymptotes, we don't have any asymptotes. Continuity is
increases from 0 to infinity and decreases at negative infinity to 0. The extrema is absolute minimum of 0 at x equals 0. The domain is negative infinity to infinity. The range is 0 to infinity. And the end behavior is a limit of f of x from x to infinity and a limit of f of x equals infinity and x to negative.
The last one is an exponential function where the formula is f of x is b to the x power, and we chose for our first value of b to be 1/2, so that's the graph. The domain is negative infinity to infinity. The range is 0 to infinity. There's no extrema, no symmetry. Boundness, it's bounded at 0.
Bounded below.
Bounded below. She didn't know which one. Okay, so the boundness is bounded below. The asymptotes, there's only a horizontal asymptote at y equals 0. It is continuous. It decreases from negative infinity to infinity. The limit is limit of f of x from when x is approaching infinity is 0. And the limit of f of x when it is approaching negative infinity is infinity. Do you want me to do both? The next one is x is 2 to the x power. The domain is negative infinity to infinity. The range is 0, infinity. There's no symmetry or there's no extrema. It's bounded below. The asymptote, it has a horizontal asymptote of y equals 0. It is continuous. It increases from negative infinity to infinity. And the limit of f of x, where x is approaching infinity, is infinity. And the limit of f of x, where x is approaching negative infinity, is 0.